Two of the hardest programs in Chapter 6 are the program that asks you to print out all of the numbers that are prime that are less than a number like 20. So we want to print out all of the prime numbers less than 20 and the card class. And I will do a separate recording on the card class, but probably the harder of those two is this prime number one. So before we jump into everything we need to do to figure out all the prime numbers less than a certain number, I'm going to show you how you would write a loop to figure out if a given number is prime. So what if I want to figure out if 20 is a prime number or not? I don't care about any of the numbers underneath it. I just want to know if 20 is prime. And I'm using 20 because that's the one they used in the example. So when I'm finally done with my whole program, I can check my answer quickly against their answer. So I don't have to sit down and figure out on my own all the prime numbers less than 20. I can compare my output to the sample output and know whether or not my program is working. So I'm going to set up a variable to hold 20. And the first thing I'm going to do is just show you how to figure out if a number is prime or not. So it's nice to use a Boolean variable here, and I'm going to call it prime. I'm going to make an assumption. I'm going to assume and default this variable to true, assuming that every number is prime. When I figure out a number is not prime, I will flip the value to false. You can do it the other way. You can assume they're all not prime and flip it when you figure out they are prime. Matter of personal preference. I like to do it this way. I think it's a little easier, but you could do it either way. There's not necessarily a right or wrong on that. So I'm going to assume the number's prime until I determine it's not, at which point I will flip this to false. So the easiest way for me to figure out if a number is prime is to take that number and divide it by every number less than itself, excluding 1. And of course, I'm not going to divide it by itself. Those two do not help me determine if a number is prime or not, because every number is evenly divisible by 1 and by itself. So going from 2 to 1 less than the number in question, so in this case 2 to 19, I'm going to divide 20 by each of those numbers. If I get a remainder of 0 at any point, the number cannot be prime, and I'm going to flip my Boolean to false and move on. However, if I run through every number and I don't get back a remainder of 0, I get back a remainder greater than 0, I know the number is still prime, right? The definition of prime is that another number can go into it evenly with the remainder of 0. So when I get back a remainder that's not 0, the number is still potentially prime. It's when I get a remainder of 0 from any number divided by it that is less than it, excluding 1, that I know it's not prime. So in my for loop, I'm going to start with 2 for my counter. Why am I starting with 2? 1 doesn't help me. I don't want to divide it by 1. That doesn't help me determine if it's prime or not. All numbers are evenly divisible by 1, so there's no point in starting at 1. So I'm going to start at 2, and then I'm going to go 2, 3, 4, 5, 6, right? I'm going to add 1 to the little I counter each time to make sure I'm dividing it by every number less than itself. And here my Boolean expression will make sure that I divide it only by the numbers less than itself. So when num gets to 20, since my number is 20, I will stop the loop. 20 divided by 20, of course, is going to have a remainder of 0. That does not help me determine if it's prime. So this is a case where I pretty much want to do less than num. If you're really insistent upon doing less than or equal to, you'd have to do num minus 1. So it would stop 1 short of the number. But I like to do less than num here. And so what I'm going to do is every single time I'm going to divide the number 20 by whatever number I'm on, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to 19. And I'm going to use the mod operator. I don't care about the answer, I care about the remainder. And I'm going to put this in an if statement and turn it into a Boolean expression. if 20 divided by 2, 3, 4, 5, 6 on up, at any time, if that results in a remainder of 0, meaning I found something that divides into 20 evenly other than 20 or 1, I am no longer prime. I'm going to flip my prime Boolean to false. And so at that point I could do a print line, print out whether it's prime or not. I could print out system.out.println prime, and I could print out true or false. Or I can do a little nicer if statement here, where I've set up a little variable to say prime or not prime. So if prime, change that variable to that string to say prime, otherwise say not prime. Remember, this is the same as saying prime equal true. Two ways to say it. If it's not true, it must be false. Therefore, it's not prime. If the value in prime, the variable, is false, the number is not prime. And then I literally print out num is prime or not prime. So you can see I ran it for 20. 20 is not prime. Now the problem with this is if I find out when I divide 20 by 2 that it is not prime, I'm still going to check 3, 4, 5, 6, 7, 8, 9 up to 19. I'm going to be inefficient and eat up processing time. So once I find the first instance of where it's no longer a prime number, I can actually break out of the loop here. Save myself a little compile and processor time, really, not compile time. And I can find out quicker if it's prime. Some people frown on using break statements in a loop to stop the loop, others don't. So what I'm telling you here is this break more or less stops the loop from running, and it comes down here and picks up. So this loop's going to run one time because it's going to figure out that 2 divided by 20 is not prime. It's going to set prime to false. It's going to stop running. It's almost like I set I equal to num to force it to break more or less here, okay? So it stops executing. This one only ran one time, and then it goes on ahead and prints out whether or not it's prime. So now that we have a mechanism for figuring out if a number is prime, now we've got to think of a mechanism for saying, let me check every single number less than 20. 2, 3, 4, 5, so let me check all of those. Which of those are prime? So we're really going to have a tricky situation here. We're going to have to use a nested loop. So here I've come down and I'm just visually giving myself this line here to show me where my second chunk of code is. And I print out all prime numbers less than 20, okay? Now here's where it gets tricky. I'm going to put that same for loop right here with the if. I'm putting that all in there. But notice I'm nesting it within a while loop. Here's a while loop that's outside of the for loop. That's perfectly acceptable. Now this is where it gets tricky. I've got to have a separate counter for the while loop because I want to make sure I hit every number between 2 and 19. I want to go to 2 to 3 to 4 to 5 up to 19. So I'm going to have a separate counter here. I'm starting at 2. Notice right before the final brace of the while loop, I'm going to make sure my counter goes to 3 and then to 4 and then to 5 all the way up to 19. So I make sure I check every number. That's what the outer loop's doing. It's making sure I cycle through every number from 2 to 19. I don't want to check 20 or 21 or anything higher than 20. So I'm going to loop as long as this outer counter is between 2 and 19, as long as it's less than 20. Here I've got to reset prime to true every time the while loop runs, so that every time I check a new number, I'm back to assuming it's prime, and I make sure I don't trick myself. Because if I don't do that, the first time I find a non-prime number, it's pretty much going to stop. It's going to think every number after that is not prime. Okay? So if I don't put this here, I have a logic error. And I really don't get anything, right? Because let's think about this. I have to think for a second. I defaulted prime. I defaulted prime to true. Then I came up here and I figured out that 20 is not prime. And then I never changed it. Prime stayed false even though all these loops ran. And so since prime was never true, remember this is equals true, right? So prime stays false. So all through this, even though I waste the time to run this calculation, prime is false. I never get it set to true. And so since it's not true, nothing prints out. So that's a logic error. I've got to make sure each time this outer loop goes from the number 2 to 3 to 4, for each number I'm testing, I've got to reset prime to assume it's true again. Then I use my inner loop to actually take the number, so I'm on 2. Now I need to check and see, is 2 prime? So 2, blah, blah, blah. Because I is 2, 2 is not less than 2, right? This for loop never executes for the number 2, but because I started out assuming the number was prime, I correctly will get that 2 is prime. It'll print out 2. So see, all the assumptions I make totally control the way the rest of the code works. So my assumption that a number is prime works really well for me with the number 2. I'm not even going to check 2, and it's going to correctly figure out that 2 is prime. So now my counter becomes a 3. So now counter is 3. So I less than 3, I want to start at 2, divide 3 by 2, see if it is prime or not, right? So now counter is 3, divided by 2, I get back a remainder, so I know that 3 is prime because I don't get back 0, I get back an actual remainder. The loop stops, the only number I can divide 3 by is 2. I still have the assumption because prime was true that 3 is prime and it correctly will print out 3. Now counter goes to 4. I resets itself to 2. So as long as I is less than 4, I'm going to loop. So I divide 4 by 2. I get back a remainder of 0. I immediately set prime to false. I break out of the loop, out of the for loop, not out of the while loop. The while loop is still running. Then I'm going to print out, I'm not going to print out 4 because it is not prime. Prime is false for that. This if statement doesn't fire off. Now counter goes to 5. This while loop is still running. I resets itself to 2. Counter is 5. I divide 5 by 2, I get a remainder. I divide 5 by 3, I get a remainder. 5 by 4, I get a remainder. Prime stays true. That Boolean variable stays true. I break out of the loop, I come down, and I print out 5 correctly, okay? Now counter's at 6. I is back to 2. 6 divided by 2 gives me a remainder of 0. I flip the word prime to false. I break out of the loop. Since 6 is not prime, prime is false, this if statement does not fire off. I do not print 6. And I keep running. So the outer loop is going to run from 2 to 19, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. The outer loop is going to run 18 times from 2 to 19. That is 18 iterations, 18 repeats. It's going to run 18 times. The inner loop is going to run more than that probably because I'd have to do the math. But when I'm running it for 3, it runs once. For 4, it runs twice. For 5, it runs 3 times. For 6, it runs 4 times. So that inner for loop is spinning, 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 going many more times than the outer while loop. So it runs many times, and the outer loop runs 18 times. And now that I've corrected all my logic errors, I should get back my correct answer, which I would then flip back to the assignment write-up, and I would say, does my output match theirs? I've already done that. Yes, it does. And now I've got all the prime numbers less than 20.